Welcome back from intermission. Find your seat if you can.
I am Brian W. Mulligan, also known as Astrobit.
I'm Sinclaire M. Manning, also known as Major Merger. And we're here to present you with this month's top news stories in astronomy. The volume, the microphone. If I stand, is this better? Or no? Still not good?
I don't know.
We have... I don't think they'll take that well. I will talk as... That's better? Okay. Thank you for letting us know.
Oop.
Wrong way.
Wrong way. What's going on? There we go.
Okay, first story of the month. So, 2 new papers have come out this month exploring the presence of lakes on Saturn's moon Titan. Yeah, a lot of Titan fans in the house. So they use data taken from our dearly beloved Cassini spacecraft. So, some people know what I'm getting at there. So Cassini flew past the massive moon more than 100 times, gathering crucial observations before the mission ended in September 2017, and Cassini was purposely driven into the surface of Saturn.
Aww.
It was a spectacular ending, though. So Shannon McKenzie, lead author on one of the papers and planetary scientist at Johns Hopkins University's Applied Physics Laboratory, analyzed an unusual phenomenon captured by the spacecraft, which is 3 small features that appeared to be liquid lakes when Cassini first spotted them, then seemingly dried up by the time the spacecraft returned to take another image. They disappeared. Ooh, spooky. So the observation suggested that the liquid either evaporated or seeped into the surrounding planetary surface. These quote-unquote phantom lakes may be evidence of seasonal changes on the moon, as 7 years passed between the 2 observations, and in that time the northern hemisphere of Titan transitioned from winter to spring. So in the second paper, Marco Mastrogiuseppe, a planetary scientist at Caltech, measured the depths of these lakes on Titan, establishing that they were more than 100 meters deep and dominated by liquid methane. So they believe the lakes are fed by local rains and then drain into surrounding subsurface caves, as channels connecting all these liquid features were also observed by Cassini. So to get a closer look at these features, NASA right now is seriously considering a project called Dragonfly, which would launch, yeah, Dragonfly fans also. So this is a mission that would launch a drone in 2025, would then travel over 9 years to reach Titan and then land on the surface of that moon. So that'd be pretty dope if it happened.
All right, next up, so we have a few updates from the planet Mars, both from the orbit and the surface. So first, the Mars InSight lander. If you've been coming, you've heard me talking about it in news before. So it's now placed all of its instruments on the surface of Mars. It's got a seismometer as well as a heat probe. So the heat probe is supposed to be hammered into the soil to a depth of about 3 to 5 meters to measure the amount of heat coming from the planet's interior. So they started hammering it into the surface about a month ago, and it got about as far as 30 centimeters and got stuck. So we're not really sure exactly what happened. It could have hit a rock, it could have hit gravel, or I don't quite understand how this works.
Rock.
Yeah. Or the sand might not be enough for it to grip on.
Even smaller rock.
Yes.
Okay.
So somehow it needs the sand to grip to make the hammer work, I guess, and perhaps it's not gripping enough in the sand. So there has been a model of the probe made that's been sent to Jet Propulsion Laboratory in Pasadena. They are doing experiments with that, trying to figure out exactly what it's stuck on and why. They did a couple of hammering experiments about, let's see, March 26th, so 3 weeks ago or something like that. And using the seismometer to measure the hits from the hammer and try to understand what's going on. They're still trying to figure it out, so stay tuned. Hopefully they'll figure it out and get it moving again and get it down to where it needs to be. The other news is from an orbiter. So where were we? The trace gas orbiter. The first results have been revealed, and the most unexpected thing is a lack of methane in the upper atmosphere of Mars. So the Curiosity rover previously found concentrations of methane on the surface of Mars of about 0.41 parts per billion. So about a half a molecule of methane for every billion particles of gas. And the orbiter has basically found one particle of methane so far. Its upper limit is about 0.012 parts per billion, so about 300, got that right? Yeah, a factor of 300 times less methane than expected in the upper atmosphere. So it's completely unclear where all this methane is going. One of the current speculations is that there was some large dust storms on Mars a few months back, and it's possible that the methane bonded with the dust in those storms, and it's helped wipe out all the methane in the upper atmosphere. So they're continuing looking for it, and hoping to, and of course theorists are going to be, going overboard and coming up with their own reasons on this.
I didn't realize disappearing methane was the theme for this month. But it's all on Titan if you're looking for it.
It just went into the caves.
Yeah. All right, maybe some of y'all heard of this. Israel's first moon lander came up just short in its historic touchdown bid on April 11th. The robotic Bereshit spacecraft, built by Space IL and Israel Aerospace Industries, aimed to become the first Israeli craft and the first privately funded mission ever to land softly on the moon. But the little robot couldn't quite make it, crashing into the lunar surface around 3:25 Eastern Time. So Mission Control lost communications with the spacecraft when it was about 489 feet above the moon's surface, but the spacecraft captured this selfie on the left when it was about 22 kilometers above the moon, so you could see the Israeli flag and "Small country, big dreams," which is a very nice sentiment. Yeah. So the lander launched on February 21st atop a SpaceX Falcon 9 rocket and was captured by the moon's gravity on April 4th. The main goals of Bereshit were not strictly science-related. They actually involved advancing Israel's space program, increasing the nation's technical know-how, and getting more young people interested in science, technology, engineering, and math. So all great things. Perhaps for us in Austin, this ended up being a little interesting too. As part of the program, a limited number of celebrities, influencers, and dignitaries were invited to contribute to the Lunar Library, which was a device resembling a CD containing 100 gigabytes of compressed data that was sent on Bereshit. And somehow the opportunity to contribute to this Lunar Library was presented to Austin's own mayor, Steve Adler. I'm not sure what his connection is to the Israeli aerospace industries, but somehow he got on their list. And he provided for this Lunar Library one of Austin's best-kept secrets. And does anyone know what it was? Yeah, he provided the top-secret recipe to Kirby Lane Cafe's Kirby Queso. One of the weirdest things I've ever heard.
Hopefully not the only copy, considering it is now in pieces.
So though, apparently there is a small chance, since it was just a small little compact disc, there's a chance that the library is still intact. So if aliens, or us on the moon one day, should ever come across it, they could potentially have access to more than 80,000 images of books, photographs, documents, a key to 5,000 human languages, and the recipe for one of Austin's most beloved melted cheese dips. Yeah.
I assume that means Kirby is going to be the first restaurant on the moon.
Absolutely, yeah.
Okay, the biggest news story, of course, of this month.
I should have brought up my beer to help me get through this story.
Yeah, this is going to be a long one. So a team led by Katie Booman of Harvard have produced the first image of a black hole. So, yay!
The excitement went away. They already saw this in the first talk.
We've already talked about it. So Jonathan, of course, has already talked about this. I'm going to talk about it a little bit more. So the black hole seen here is in the center of the M87 galaxy. The image was taken using the Event Horizon Telescope. I'll talk a little bit more about that in a moment. The orangish areas that you see here is light given off by the warm gas or dust in the accretion disk around the black hole. And the dark area is the shadow of the produced by the black hole itself. So the black hole has a mass of about 6.5 billion suns, a radius of about 2 billion kilometers, or about 10 times the size of our solar system. The measurements of the size and the mass of the black hole through this image have produced the first direct confirmation that our understanding of physics of how these things, how big they are and how massive they are, the first confirmation of that physics is actually correct. Yay!
We did something right.
Yeah. In fact, it matches extremely well with predictions. It's fantastic. So and then the gas and dust that's giving off light within the disk, as Jonathan showed you, it's material that's falling into the black hole. An artist's rendition of what this looks like you can see on the lower right from the movie Interstellar. We also saw a little bit of a similar thing in the intro video from, what was that movie? Black Hole? Oh, that was Interstellar. Okay.
Oh, I thought you were joking.
No, for some reason I thought it was a different movie. It looked the same, but yeah. So what you're essentially seeing, you've got the black hole itself. So looking at this image on the lower right, we've got the accretion disk is here, and you see this bright ring around the black hole. Well, that ring is actually the accretion disk on the back side of the black hole. So the light is getting warped around the black hole, and you're able to see the accretion disk that's actually directly behind it. In this image here, we're probably seeing the exact same thing. So it's likely that perhaps this is the front of the accretion disk that we're seeing, and this dimmer glow up here is probably potentially the accretion disk that's behind the black hole that's getting warped around it. So Interstellar had it right. That Interstellar was the first time that it was a computer model. They spent a lot of processing time just producing those images, and it looks like those images are actually what black holes look like. So it's pretty cool.
But wait, there's more.
So this image itself and also seeing this effect is once again confirmation that Einstein's theory of relativity is correct, in case we need more confirmations. Okay, so one comment that I've heard is that this is a very fuzzy image. Why is it so fuzzy? Why does this look so boring?
If anyone says that, please just give them a little smack for me. Okay.
So there's two factors. One is essentially how light works, and two is what resolution you can get from telescopes. So while this black hole itself is extremely large, it's also very, very, very far away, so about 55 million light years. At that distance, it appears in the sky to be a width, an angle of 10 micro arc seconds. And of course, everybody knows what that means. To give you a better perspective, imagine taking one of your hairs. You can, if you hold that hair up close, you can see it pretty easily. If somebody's holding that hair across the bar, you can't see it very well. It looks really, really tiny to you. The size of this black hole, appearing as it does from Earth, is equivalent to holding a piece of hair in Kansas City and looking at it here from Austin. So we need a really good telescope in order to do that. The bigger the telescope, the better. The Hobby-Eberly telescope at McDonald Observatory in West Texas has a diameter of about 10 meters. The Hobby-Eberly telescope would be able to see that hair if it's in the town nearby McDonald, not Kansas City. So in order to achieve the resolution to see this, and I'll bring up, other way. I'll bring up my next slide. We spread telescopes out across the Earth, and we essentially make our telescope the size of the Earth. Of course, it's not possible to make one giant telescope that big unless somebody has a lot of money here. So if so, we've got tip jars right over there. So we take several small telescopes and combine the information together from all those telescopes spread across the Earth, making one effective telescope that's the size of the Earth. You might have seen this picture of Dr. Booman with all of her hard drives here. So those are the hard drives that are collected from all these different telescopes around the Earth. She combined that information together, used special computer processing that she developed in order to create those fantastic images, and that's the only way that we're actually able to resolve that black hole.
He's still going.
Still going. So just a little bit more. So the AHT, that's not the only black hole that it looked at. It looked so far at least 2 other black holes that we know of. It looked at the black hole in the center of our own galaxy. That black hole is a little bit smaller, but it's much, much, much closer to us. So expect to see images of that probably in the coming months, and those are probably going to be much more spectacular than the one we saw even of M87. So keep listening. It's going to get even better.
All right. I knew there was a reason I let you do that story. All right. Last up, we have astronomy not in the news. So this is a story that maybe didn't get as much attention as we think it deserved, but is interesting all the same, and we'd like to share it with you. So astronomers have seen a glimpse of what may happen to the Earth once our sun runs out of fuel and can no longer sustain nuclear fusion in its core, which will happen in about... I mean, that's a fair reaction. Luckily, we have about 5 billion years until that happens. So you got some time to prepare. So while the lives of more massive stars end in colossal supernova explosions, stars like our sun, which are a bit smaller, eventually shed their outer layers to become planetary nebula, leaving behind only their hot, compact cores, which are known as white dwarfs. As these stars evolve and die, what happens to the planets, like our Earth, that surround them? So astronomers have observed a white dwarf about 410 light years from Earth, with a mass that's about 70% the mass of our sun, but is contained in a radius similar to that of the Earth. So that's a super compact, super dense object. So Christopher Manser from the University of Warwick and other collaborators observed this white dwarf with the 10.4 meter Gran Telescopia Canarias in Spain's Canary Islands. And they found periodic fluctuations in the spectrum of the white dwarf, which occurred every 2 hours. And they concluded that a ring of gas streaming from a planetesimal orbiting within the disk is the most plausible explanation. And that's what this artist's impression is here. You have the white dwarf in the center, the planetary nebula with this disk, and then your half-eaten planet orbiting around. So with a period of only 2 hours, the planetesimal orbits very close to the white dwarf, and it must be very dense to withstand the gravitational forces from that white dwarf. So the researchers propose that it must be composed of heavy metals like iron, possibly a fragment of the core of a larger rocky planet, very similar to our Earth's core. So this is the second planetesimal found orbiting around a white dwarf, and studies like this are helping us understand the ultimate fate of planetary systems like our own. So that's us in 5 billion years, maybe. And with that, thank you all for listening.
Thank you all for coming. Enjoy the rest of the show.